Hi guys, welcome to Learn Extra Exam Revision. This is the geography session, and today we are going to be concentrating on paper number 2, the map work paper, and more specifically on questions coming out of question 1 and question 2, looking at calculations. The reason why we are doing this session today is simply because the map work paper accounts for 25% of your complete geography marks. So it's absolutely vital that you know how to do these calculations and that you achieve the marks that you need to be achieving in this specific section. These are marks that are up for grabs. It's no theory, it's no interpretation, it's straightforward calculations that you should be getting right every single time. So as we work through it today, please just take note of a couple of the tips that I'm going to be giving you for each calculation, as well as the mark allocation, and then as well as the equipment that you will require for that specific question. So without further ado, let's move on and have a look at the breakdown for today's lesson. A quick checklist of what we're going to be needing. You cannot go into a map work exam without having the correct equipment. You need the tools in order to accurately measure and get the information you require off of the map so that you can put them into your calculations. So having the correct tools is vitally important. Today, I've brought the tools that you are going to require. You need a 30 centimeter ruler, I've got it, with clear centimeter and millimeter markings on it. A clutch pencil with a very sharp tip so that you ensure your measurements are accurate. An eraser to rub out all of the pencil markings that you make onto your paper, simply because these are resources that schools take in and they are needed in years to come. So we want to keep these maps in pristine condition. A protractor. Today I've brought a 360-degree protractor. Some of you guys are going to have a 180-degree protractor, but that's not an issue, because if you have to measure greater than 180 degrees, you're simply going to turn it around, but we'll get to that a little bit later on. Very importantly is a 30 centimeter or longer piece of string. The reason why you need this string is because you'll be required to measure a distance that's not in a straight line, so an irregular distance, or not irregular, but a curved distance, such as along a road or a railway line. So you need that piece of string so that you can get that measurement down. So if we look at the notes here, just a quick checklist of what we're going to need, how to approach paper number 2. We're going to be working obviously with a topographical map as well as an orthophoto map. The topographical map is the map that has the scale of 1:50,000, and the orthophoto map is the one that has the scale of 1:10,000, and as the name suggests, it looks like a photograph. We'll get to a little bit more about that just now. The calculations that we're going to be concentrating on are the map index. We're going to be looking at gradient. I just want to spend 1 second quickly. Every single paper that has come out in the final years, final exam over the years, has included a gradient question. This is a very, very, very important calculation to concentrate on. So when we go through the gradient calculation, please pay careful attention. Then we're going to look at current magnetic declination. So we're going to look at calculating a declination for this specific year that we are in. We're going to look at a cross-section. Cross-sections usually take up a lot of time, so what they tend to do is just give you the axes on which you need to plot the points and then connect them up. So it's more of like a freehand type of cross-section instead of a more accurate traditional cross-section. We'll look at coordinates. So this is location. We'll be looking at bearing, true bearing, and magnetic bearing. That ties in to current declination when we're looking at magnetic bearing. Looking at, first of all, simple distance, area, and then the one that you guys tend to be scared of is vertical exaggeration. All of these calculations are not going to be in your final exam. However, for this lesson, I'm going to be covering all of these calculations so that you've got a sound foundation going into your exam. It's important that you know all of these calculations because you don't know what to expect. I can, with a certain degree of confidence, tell you that you are more than likely going to get the gradient question in your final exam. So best you are well prepared for that specific question. Right. The first question we're going to look at today is a question that has been adapted from the November 2012 paper, question 1.5 and 1.6. These are multiple choice questions. They deal with directions and they also deal with the map index. So let's have a read here. The questions below are based on the 1 to 50,000 topographical map, 2829 AC Harry Smith. That is the name and the code, as well as the orthophoto map of part of the mapped area. Various options are provided as possible answers to the following question. Okay. For question number 1, these multiple choice questions, they're going to ask you basic calculations, and they're going to also ask you to identify basic features. There's no interpretation and actual engaging with content on the map. You're simply going to have to identify certain features, or you're going to have to provide a simple calculation and choose the correct answer from the options given to you. So in this first question here, let's have a look. 1.1. The Stakfontein Dam is to the what of the town of Harry Smith? Okay, this here is referring now to direction. So this is a question that you should be able to answer pretty easily. This is the Harry Smith map that has been trimmed down a little bit, but here we need to look. So the question stated, in which direction is the Stakfontein Dam, here it is, from the town of Harry Smith? Here it is. Okay, in which direction it is. If we join those two and we look at that direction, what direction is that? Simple enough. Here, this is definitely going to be in a southwesterly direction. Okay, quickly, if we have a look at the points of a compass, we have north, east, south, and west. Okay, this might seem a little bit mundane, but very, very often you guys are getting the east and the west mixed up. Okay, so you're going to tell me southeast. Okay, southwest. Let's go back to the answers. The options given: A, southwest; B, southeast; C, south; D, west. We identified the answer as being southwest. That's as easy as direction gets. The only thing you need to remember or keep in mind is don't get your east and your west mixed up. That is the most common mistake. So draw a little compass, or the four main points of the compass on the corner of your page, just so you can refer to it and you don't make that silly mistake and end up losing 2 marks for nothing. Okay, that would just be a travesty. Right, moving on to a more complicated type of question, but still pretty basic. The map index to the south of 2829 AC is. So we are looking at a map index that is to the south. It's got direction connotation to it, so you need to know where the south is. But more importantly, you need to know how to work out where or what the code of the map is going to be to the south of 2829 AC. We're going to cut to the map that I have here on the desk, so that I can zoom in and show you where on this map you can look at the index of the map. On the screen now you can see the index for the Harry Smith map, 2829 AC. We need to understand and figure out what 28 and what 29 AC actually means. If you look carefully here, 28 refers to the 28th line of latitude. So the lines that run from east to west, and 29 is the lines of longitude. So the north-south lines, the lines that run from north to south. In the top left-hand corner, we have 28 degrees. 28 degrees, and followed by the line of longitude, which is 29. So 29 refers to the 28th whole degree line of latitude, and 29 refers to the whole degree of the 29th line of longitude. The letters AC is what we are more concerned with now. The letters AC tell you in which block or which area of that degree squared made up by 28 and 29 AC will be found. Looking at the question, the map index to the south of 28, 29 AC is what? So how we need to try and work this out, figure it out. If we draw it out, so here we draw the 29th line of longitude, and here we have the 28th degree of latitude. The next degree of longitude is going to be the 30th degree, and the next degree of latitude is going to be the 29th degree of latitude. So we are more concerned, we are referencing this map off the top left hand corner of 28, 29. This square that has been created, the square 1 degree squared of latitude found on the surface of the earth, this square gets divided into 4 blocks, into an A block, into a B block, into a C block, and into a D block. So we've got a big block A, a big block B, a big block C, and a big block D. The reason why this happens is so that the entire degree squared, it actually covers a substantially large area on the surface of the earth, and we're going to be ending up with these massive topographical maps if we were to have one map per degree square. So they break them down into these 4 quadrants of an A, B, C, and D. From there, they need to get broken further down one more time. So each quadrant, so big block A, is going to be broken down into 4 smaller quadrants itself. And those small quadrants are then a suitable size to have a 1 to 50,000 map cover. So it's for convenience sake, and it's also so that we know where a map fits in anywhere on the surface of the earth. So coming back to the screen, each block A, B, C, and D gets divided into a big block A, big block C, or small block A, sorry, small block C, small block D. So this is going to be big block A, A. This is going to be A, B, A, C, A, D. And the rest applies throughout the entire diagram. So I'm just going to draw them in. BA, BB, BC, BD, CA, CB, CC, CD, DA, DB, DC, DD. So that's how the entire degree squared gets broken up, with those reference points using letters A, B, C, and D to reference where in the grid that the specific map is going to be located. So let's locate on this grid where the Harry Smith map is going to be. So if you just go back up a little bit, 28, 29, AC. So the Harry Smith map is going to be covering this block. 28, 29, block AC. Look at the index, 28, 29, AC. So now we know where the map fits in terms of the index of maps. So we need to now answer the question, and the question stated, which map would you find directly south of the Harry Smith 2829 AC map? And it's simply a matter of referring back to your grid. If this is where the Harry Smith map would be, the map directly to the south is going to be still found within degrees 28 and 29, but the index or the grid, the position of that map in that degree square has now changed. So the answer is going to be 28, 29, but now we are covering, and I'll do it in a different color. Now we are covering block CA. So let's go back to the answers and see where 28, 29, CA is, and there's your answer. 28, 29, CA. When answering these types of questions, it's important that you draw the diagram that I've just drawn. Take the time, once again, to draw it out so that you have a visual picture of exactly where a map is going to be located. Because the trick here, if they try and give you a little bit of a curveball, they will tell you, and I'll get back to an example now, perhaps to the map to the southwest of the Harry Smith map. What's going to happen then? Because then you need to just think one step further ahead. So if we go back here, if they wanted the map to the southwest of Harry Smith, here now you would have to change the degree squared, because 28 and 29 refers to this entire degree squared. If we were going to the southwest, we'd be having to look at an entire different degree squared block. So these numbers at the top are going to change. All right, we are going to go back 1 degree of latitude, longitude. So it's actually going to end up being 28, 28, not 28 and 29. All right, that is something that you need to keep in mind, but that is a mistake that you can easily avoid if you simply draw the diagram. You can see if it's going outside of the degree squared in which your map is found. Then you know you need to change the number at the top here of either the number of latitude or the degree of longitude. All right, so just make sure that you're aware of that at all times. Moving on, let's continue. Question number 2. Here we're going to actually start doing a couple of calculations, and here we are simply doing the easiest of all the calculations, a simple distance calculation. Looking at the map, the typical type of question that you're going to get is drawing or calculating the distance of a straight line on the map. They will give you, in this example, a landing strip, or they will give you another example of calculating the length of a road. But a straight line distance, they will ask you sometimes to calculate a distance, a straight line distance between a trigonomical beacon and a spot height, for example. All right, here you simply have to measure out with your ruler, apply it to a formula, get a distance in centimeters and convert it into meters or kilometers, depending on what the question states your answer needs to be in. So let's have a look at this example here. I'm just going to erase here what I did. Okay. Calculate. So we're going to use our calculator. The length of the landing strip in block H1. The example that I have here has been zoomed in onto H1. This is block H and 1. That's where we found the landing strip. If we take and we calculate the measurement, this distance here measured out to be 1,8 centimeters. So now we're just going to refer to the map, have a look where we find it on the map. I'm going to show you with the ruler, and then we'll continue with the calculation. So as you can see here on screen now, I've zoomed in on the actual map, not a cutout, and here in H1 we find the landing strip. It's a simple straight line distance. Here we are going to be very accurate when we measure, and we are going to take the measurement from the edge of the map where the landing strip exits to the map, and we are going to, with our ruler and our pencil, our clutch pencil, to ensure accuracy, we are going to measure that distance and how it comes out. All right, I've already done the measurement before this, and the measurement was 1,8 centimeters in length. We need to take that centimeters and we need to apply it to the distance formula, and we need to come out then with the answer at the end. This is a simple calculation to do. All right, so let's now look at applying this measurement into the distance formula. Take note that the answer must be in kilometers. They don't want you to answer it in meters. You need to be able to convert it into kilometers. So distance What is the formula? D for distance is equal to MD multiplied by S. In that formula, MD stands for map distance and S stands for scale. The scale that we are obviously using is on the topographical map, and this scale is 1:50,000. So we're going to apply the number of 50,000 to the scale portion here of the formula. So distance is going to equal 1.8 centimeters multiplied by 50,000. And that is going to give us an answer that will be in centimeters, but it will be in real life centimeters. The biggest mistake made when it comes to calculating a distance is that the unit of measurement you put it into after you've multiplied it by the scale is different to the one that you initially measured. Okay, that is completely incorrect. If you measure in centimeters multiplied by the scale of 50,000, the answer, the outcome, will still be in the unit of measurement of centimeters. Don't change it to meters or into kilometers. All right, it needs to stay in centimeters. Only from there will we then convert it into meters and then into kilometers. So going back, we'll take out our calculator. We're going to go 1,8 multiplied by 50,000. That gives us an answer of 90,000 centimeters. So 1.8 multiplied by the scale is 90,000 centimeters. This now is a real life distance in centimeters. Why do they ask us to convert it into a meter or into kilometers? The reason being is that we don't speak about distances in real life as in centimeters. You don't say to your friend, oh, I'm going to walk to the shop, but I think it's about 1.4 million centimeters. It doesn't make any sense. Okay, we say 1.4 kilometers. In our minds, that's how we view the world. That's how we rationalize with space. So we have to put it into meters or into kilometers for it to actually make some sort of sense to us. We have not been trained or taught to deal with distances in real life in centimeters because the unit of measurement is too small. So we need to convert this 90,000 centimeters into bigger units of measurement. So if you increase the size of the unit of measurement, all right, that means the number is going to come down. So all you need to know here is how many centimeters are we going to find in 1 meter. So let me just, I just want to do it on the side here. We know that 100 centimeters is equal to 1 meter. We know that 1,000 meters is equal to 1 kilometer. That's all you need to know. So if I take 90,000 and I divide it by however many centimeters here at the top, 100 or in 1 meter, so we divide this by 100, it's going to convert this unit of measurement into meters. So if we just cross off the zero, simple mathematics, distance is going to equal 900 meters. They wanted the answer in kilometers. So we need to put that answer in kilometers. We know that there are 1,000 meters in 1 kilometer. So if we divide this meters answer by 1,000, it's going to give us the real life distance. So distance is going to equal 0.9 kilometers. That's your final answer. All straight line distance, or any distance calculation for that matter, follows the same step. So don't worry about what the number is. Just punch the numbers into the equation and follow the same steps. So if you've measured in centimeters, get the answer once you've multiplied it by the scale, divide it by 100, divide it by 1,000, and it will convert it into meters, then into kilometers. All right. I know a lot of you out there will probably will say, oh, why don't you just divide it by 100,000? You can do that, okay, but I'm just want to go through it step by step so it makes sense to you and that you understand why you can actually divide it by 100,000. At this point in time, I just want to please warn or highlight something to you. Very often, if you're dealing with the 1 to 50,000 map, you've been taught just to simply multiply it by 0.5. If you've measured in centimeters, multiply it by 0.5 or divide it by 2. You would be absolutely correct if you did that to convert it directly into a real life kilometers. So if you measured 4 centimeters on the map, for example, you times it by 0.5 or divide that answer by 2 and you come out with 2 kilometers. You're absolutely correct, but you may well lose marks in your final exam for not showing the steps. All right, so it's very, very important that you show all of your steps. Don't just jump to the final answer. You can use that shortcut as a check to make sure you've got the right answer, but don't rely on it as your method of answering the question. Go through every single one of the steps. That is very, very important. Right, knowing how to calculate the distance is very, very important, because distance is used in the other calculations that we're going to be doing. So let's move on. The second question we're going to do is also a distance question, but this time it's just a little bit different, and I'm not going to go through actually the entire distance calculation again, but just highlight that for this question, instead of being a straight line distance, it is a irregular or a curved distance that you need to do. So this is where you're going to use your piece of string. You're going to start, well, you're going to use your string to lay on along this curved line and then calculate the measurement of that string. So calculate the distance from the T junction on the N5 and the R74 in block C6. So this is C6, this is block C6 here, and the T junction, this is the R74, and this is the N5. Heading in a westerly direction, this is towards the west, to Kestel. Now Kestel is not on the Harry Smith map. You'll see here that Kestel is actually off the Harry Smith map, and they tell you that it is 31 kilometers in that direction. So this question has typically got now 2 parts. All right, calculate the distance from the T junction heading in a westerly direction to Kestel. So they want you to calculate this distance in kilometers, and then you're going to have to add on 31 kilometers. So very quickly punching in those numbers, the measurement I did previous to this was 19.5 centimeters. So simple distance calculation, distance is going to equal 19.5 centimeters. Okay, and that's going to be, take out the calculator, 19.5 divided by 2 is going to equal 9.75 kilometers. 9.75 kilometers. So this distance here is this distance along the road from the T junction to the edge of the map. From here, we need to now add on the 31 kilometers, and that's what we'll do next. So it's going to be 9.75 plus 31 kilometers, and the total distance is going to equal 40.75 kilometers. So in your final exam, you're going to get a mark for that, and you're going to get a mark for adding it on there. Right. Okay, guys, we've been going for a little bit now. I think it's time for a well-deserved break. We've gone through a number of questions pertaining to this concept of distance. So go grab yourself something to drink, and we'll see you back in 5 minutes. Welcome back, guys. I hope you are well rested after that short little break. Question number 3 for today states, and this was adapted from the 2012 final examination, the supplementary examination. Calculate the area in square kilometers. This is very important. Of the urban area demarcated by the dark line on the topographical map. So this extract here is the zoomed in of the area covered by the topographical map on the Harry Smith map. The area covered by the orthophoto map on the topographical map. When calculating area, you need to calculate a length, and you also need to calculate a breadth. So we all know through our maths days that area is equal to the length multiplied by the breadth. In map work, it is exactly the same. However, there's one slight change that I personally like to do. I don't like to write the formula as length times breadth. I prefer to write the formula out to avoid the common mistake that is made. So the formula that I write out always is area is equal, and then a bracket, the length multiplied by the scale, which you will notice is a simple distance calculation. Then we multiply the breadth by the scale. So this is actually a distance calculation, and this is a distance calculation. The reason why I do this is because one of the most common mistakes is that you measure your length and your breadth on the map. You then multiply those 2 centimeter measurements to get the area in centimeters squared. Then you multiply that centimeter squared area by the scale. That will extrapolate the wrong area in kilometers when you apply the scale to that centimeter squared measurement. So what you need to do is get a real life length in kilometers, a real life breadth in kilometers, so those 2 distance calculations, then multiply them together to get your area in kilometers squared. So for our example that we're dealing with now, we've got a length of 11.1 and a breadth of 9.8 centimeters. So the length equals 11.1 centimeters. The breadth is going to equal 9.8 centimeters. Welcome back, guys. I hope you are well rested after that short little break, had something to drink, and you're ready to focus and get back into looking at calculations required in Map Work Paper 2 at the end of the year. We finished off looking at distance and looking at a curved line distance. Now we're going to take those distance calculations and build on them. So now we're going to look at calculating an area and look at one of the common mistakes that you guys make when you're calculating area. I'll talk about it as we go through. So let's have a look at the question. Question number 3 for today states, and this was adapted from the 2012 final examination, the supplementary examination. Calculate the area in square kilometers. This is very important. Of the urban area demarcated by the dark line on the topographical map. So this extract here is the zoomed in of the area covered by the topographical map on the Harry Smith map. The area covered by the orthophoto map on the topographical map. When calculating area, you need to calculate a length, and you also need to calculate a breadth. So we all know through our maths days that area is equal to the length multiplied by the breadth. In map work, it is exactly the same. However, there's one slight change that I personally like to do. I don't like to write the formula as length times breadth. I prefer to write the formula out to avoid the common mistake that is made. So the formula that I write out always is area is equal, and then a bracket, the length multiplied by the scale, which you will notice is a simple distance calculation. Then we multiply the breadth by the scale. So this is actually a distance calculation, and this is a distance calculation. The reason why I do this is because one of the most common mistakes is that you measure your length and your breadth on the map. You then multiply those 2 centimeter measurements to get the area in centimeters squared. Then you multiply that centimeter squared area by the scale. That will extrapolate the wrong area in kilometers when you apply the scale to that centimeter squared measurement. So what you need to do is get a real life length in kilometers, a real life breadth in kilometers, so those 2 distance calculations, then multiply them together to get your area in kilometers squared. So for our example that we're dealing with now, we've got a length of 11.1 and a breadth of 9,8 centimeters. So the length equals 11,1 centimeters. The breadth is going to equal 9,8 centimeters. Now that we have our length and our breadth in centimeters, so we've measured it on the map, we can apply it to our formula. Remembering instruction number 6 all the time, we need to write the formula down in our answer. So area is going to equal length times the scale multiplied by breadth times the scale. Distance, distance. Area is going to equal 11.1 centimeters times the scale of 50,000 multiplied by the breadth of 9,8 centimeters times by 50,000. This is a distance calculation and this is a distance calculation. So let's get those distances on the calculator into kilometers before we multiply them together. So on the calculator, we've got 11,1 centimeters multiplied by 50,000, which gives us 550,000 centimeters. There are 100 centimeters in a meter, so if we divide this by 100, it will convert it into meters of 5,500. There are 1,000 meters in 1 kilometer, so if we divide this by 1,000, it's going to equal 5,55 kilometers. So our length here is going to equal 5.55 kilometers. Looking at the breadth now, we need to multiply this by the scale to get it into kilometers again. So let's just pull up the calculator. 9.8 centimeters multiplied by 50,000, which is the scale, gives you 490,000 centimeters in real life. If we divide this by 100, it puts it into 4,900 meters. There are 1,000 meters in 1 kilometer, so we divide it by 1,000 to convert it into kilometers, which is 4.9 kilometers. So we've got a breadth here of 4.9 kilometers. Now we've got them in kilometers and kilometers. These are manageable numbers to work with. We simply multiply them together. So 5.55 multiplied by 4.9. So 5.55 multiplied by 4.9, and that gives us an answer of 27.195. We can round off to the second decimal place, so we can write the answer then as 27.19 kilometers squared. 27.19, and very, very importantly, it's not a distance, it's an area. So we have squared. 27.19 kilometers squared. One big mistake that you guys make as well is that you don't put the squared in and you leave it as a distance. That is wrong. You need to have the square in there to indicate that it's an area. And that's as simple as an area gets. Two things you need to remember. Convert your length and convert your breadth into a real life distance in kilometers before multiplying them together, and write your answer as a kilometer squared, not as a kilometer, which indicates a distance. Right, moving on. The next question we're going to look at is looking at coordinates. location. You will be asked to locate certain features on a map, or you will be asked to provide the coordinates for a specific feature on the map. So they can ask this question in two ways. They'll give you a set of coordinates in the question, and they will ask you to state what feature you can find at those coordinates, or they will give you the feature and you have to provide the coordinates where that feature is located. Working with coordinates is very, very simple. It is the same as working with time. Degrees equals or is equivalent to an hour, and then every degree you have 60 minutes. Every minute has 60 seconds. So when we move through, or when we look at location and dealing with coordinates, we will work in the units of degrees, minutes, and seconds. Right at the end, I'll mention that sometimes they give you the coordinates as a decimal place. So they'll say 28 degrees, 9.5 minutes. All right, there's a decimal system that they use as well. Personally, I like to use the seconds. All right, but I will mention the decimal system in case that's how you've been taught. Both are correct, by the way. Right, examining question number 4. Yeah, we've got another extract off the Harry Smith map. Provide the coordinates. So here they give you the feature and you need to provide the coordinates of the Old Toll Bridge in block A3. This is block A3. Found in there is the Old Toll Bridge. All right. Thing you need to be aware of here is that you need to actually measure from the bridge, not where it says Old Toll Bridge. So here is the actual bridge. That's where you need to be measuring from. Right. When answering a coordinate question, the common mistake here is that you give the longitude first and then you provide the latitude. When providing the set of coordinates or answering for coordinates, you always have to state latitude first. So the west-east line first, then the longitude north-south line. So you're going to answer latitude as hours, minutes, seconds to the south, followed by a semicolon, degrees, minutes, seconds to the east. That's how you need to approach it. Don't swap them around, otherwise it's going to be wrong. And you need to indicate in which hemisphere it is in. Is it in the southern hemisphere? And it would be in the eastern hemisphere in the case of the South African map that you will always get in your final exam. Alright, so looking at this question, we want the coordinates of the Old Toll Bridge in block A3. We're going to start with the coordinates of latitude first. That is the line that runs from west to east. From west to east. Right. So the coordinates we need to start looking at here in the top left-hand corner of the map is 28 degrees and 15 minutes. That's what this line is here. It's the 28th degree and the 15th minute. We want to know where the Old Toll Bridge is. So we have to actually go down. And now you can see there isn't any numbering in this distance here. All right? Each one of these blocks that you find moving across the top and down the side of your map is the equivalent to 1 minute. So this distance is equivalent to 1 minute. This distance is equivalent to 1 minute. We know that there are 60, so this goes on 60 times to create the entire degree for 29. All right, and the same here goes for down the left-hand side of your page for lines of latitude. We've got 28 degrees, but this line now is the 15th minute. The next one down, so this one here would be 16 minutes. Our answer does not quite reach the 16th minute. So when approaching this, you need to take your pen and your ruler, your pencil and your ruler, and mark off as precisely as possible where the old toll bridge or that feature is in relation to this minute on the side of your map. So you do that for latitude, and you do the same thing for longitude. So you'll precisely draw a line that is parallel to all of these north-south lines at the top of the page. And for example, there, it would be there. So when writing out this answer, you need to then order them and sort of estimate where the seconds are going to be. So in this example, we're going to start with the line of latitude. The old toll bridge is in the 28th degree. It's in the 28th degree. It's also in the 15th minute because we are traveling, we are going to get to the old toll bridge before we reach 16. So here we have to say 28 degrees. We are still in the 15th minute. How many seconds have passed before we get to the old toll bridge? Now this is where it becomes a little bit tricky for you guys. Where you see this length, if you divide that length accurately in half, I'm just doing it very roughly for this purpose. If you accurately in half, we know that that is going to be 30 seconds. Is this answer going to be more or less than 30 seconds? Obviously, you can see that it's gone beyond 30, so it's more than 30. Take from 30 to 60, and we divide it in half again. That is going to be around about the 45th second. Is it more or less than 45? It is obviously more than 45 in this example. And here we need to now start guesstimating. 45, if we divide that by 2, add on 7.5, we're going to get to 52.5. So it's around about 55 seconds. And we indicate seconds with 2 dashes. And this is in the southern hemisphere. So you must put south. Right, so like I said to you, I prefer using the seconds when it comes to coordinates. Some of you guys may prefer to use a decimal. Remember, a decimal is a number that is broken down into 10 equal parts or 10 parts. So for example, if you have 30 seconds, that is half of a minute. So that would mean that it would be 0.5 of a minute. So if you have 55 minutes in the example that we just did, sorry, 55 seconds, not minutes, 55 seconds in the example we just did for latitude, that means that if you divide that number by 6, because 6 minutes is equal to 0.1 of a decimal, that is going to give you a decimal answer of 0.9. All right, so you can rewrite that answer as 28 degrees, 15 minutes, or 15.9 minutes. And sometimes you prefer to use a decimal. I personally prefer to use the seconds. Right, moving on. We are now going to look at probably the most common calculation that you can expect to find in your map work paper. Calculating a gradient is something that comes up year after year after year after year. It is imperative that you know how to calculate a gradient. Before I even get into looking at an example and working through a gradient calculation with you, it's very, very important that you understand and you are aware of what gradient is. If you don't know what gradient is, you don't know what the examiner is asking you, you don't know if you're saying the right thing at the end of the question. So gradient is simply they want to understand or they want to know how steep a slope is. The only way that we can express how steep a slope is by using it or expressing it as a ratio, 1 as to something. Now what do those things mean? The 1 part of the ratio refers to the vertical portion, and the as to something part of the ratio refers to the horizontal portion of the ratio in the answer. So they want to know how many steps horizontally would it take to elevate yourself up by 1 step of the equivalent distance or in the equivalent units of measurement. So how many centimeters must I walk across horizontally in order to elevate myself by 1 centimeter? And that's basically what gradient is. It's important that you understand what it is that you're actually being asked. Okay, it's very difficult if you don't understand the concept of gradient. So let's have a look at an example, and I'll explain these things in more detail as we move through. So if we look at our question, this question was adapted from the 2012 paper, question 2.1.3, for those of you who have been doing a revision with past papers. Calculate the average gradient of the slope between spot height 1797. So here is spot height 1797. And spot height 2263, here's spot height 2263, all right, in block A10 on the topographical map. Now, there is a relationship between two things. There's a relationship between the vertical and there's a relationship between the horizontal. This relationship gives you a gradient. And that's what we're working out. We're working out this relationship and expressing it as a ratio, 1 as to something. That's typically what we want to do. So the formula we're going to use, is gradient is equal to the vertical interval divided by its horizontal, and we say equivalent. The vertical interval is the difference in height between the 2 points you're measuring. Height, remember, is always given on a topographical map as in meters above sea level. You don't have to apply any formula to them. It is what it is. Meters above sea level. You simply subtract the smaller number from the bigger number and you end up with a difference in height between them. That is a vertical interval. The horizontal distance between them is a simple distance calculation that we covered earlier on, and you need to convert that answer, all right, into the equivalent unit of measurement that you use on the top or for the vertical interval, which was in meters. So instead of converting a distance into kilometers, we are now going to convert that distance into meters. So we have meters on the top and meters on the bottom. So here, this is going to be in meters. We need to then calculate this distance between them, or this distance here, as meters as well. You must have the same units of measurement. You cannot have meters on the top and kilometers at the bottom. That is not going to work. So please ensure that you make sure that that you put them into the same units of measurement. That is very, very important. Right. So let's now tackle the first portion of this and look at the vertical interval. So we're going to write them separately. Vertical interval, what is that going to equal? We're taking the higher of the two heights, and it's given to you in the question even, spot height 2263, meaning that it's 2,263 meters above sea level, minus 1797, and that's going to give you an answer of 2263 minus 1797 equals 466 meters. So the vertical interval is going to equal 400. I forgot what the answer was. 2263 minus 1797, 466. Equals 466, and it's in meters, guys. Meters. You don't have to manipulate that. It is what it is. That's what it is in real life. The second portion is the distance between them, the horizontal equivalent, and this is where it's a little bit easier. All right. This is a simple distance calculation. I measured it out already for you of 3.8 centimeters. We're going to apply that to a distance formula. So 3.8 centimeters multiplied by 50,000, okay, and that is going to give you your distance, and we need to then convert it into meters, not kilometers this time, but into meters. So 3.8 multiplied by 50,000, that gives us an answer of 190,000 centimeters. We know that there are 100 centimeters in a meter. So if we divide it by 100, that's going to give us an answer of 1,900 meters. So the vertical or the horizontal equivalent is going to equal 1,900 meters. So now we've got the vertical interval in meters, real life, and we've got the horizontal equivalent in meters in real life. Drawing another diagram, just examining quickly the relationship that we're looking at. We want a relationship of vertical to horizontal. Right. In the answer, the ratio answer, vertical is expressed as 1 and the horizontal is whatever your answer is that you're calculating. So here, we are looking at a ratio of 1 as to something here. That's the answer. So we want, in essence, this is the vertical interval portion. This is the horizontal equivalent. We want the vertical, this vertical number, we want to reduce it or simplify it into a number of 1. And that's all you have to do. All you have to do is divide it by itself. So if we look at the numbers given already, 466, 1900, we can take gradient is going to equal 466 as a ratio to 1900. Exactly what we had here, 466 as a ratio to 1900. And we put that into a ratio. Now we want to simplify this portion and we need to make it 1. To do that, we divide it by itself. And what we do on the left, we must do on the right. So we need to divide the horizontal portion by the same. So we divide that by 466. And we simplify it into gradient is going to equal 1 as 2, and get our calculator out, 1900 divided by 466 equals, and we got 4.07. We'll round off to the second decimal place. So our answer then is going to be 1 as 2, 4.07. And that is the final answer for gradient. So to recap, look on your map. You need to identify your two heights. Subtract the bigger from the smaller, or sorry, the smaller from the bigger to get the difference in height between them. And that's what we did here to get this answer. Second step, measure the distance between them. 3.8 centimeters. We applied that to a distance formula. All right, multiplied it by the scale and got a meterage of 1,900 meters because it needs to be the same as the top. We put those numbers in to our formula as a ratio, simplified that ratio down, and we got 1 as to 4.07. And that is as simple as gradient gets. It doesn't get more complicated than that. The steps that you need to follow remain the same all the time. Don't worry about the numbers that you're dealing with. The numbers are going to change all the time with every test that you write. But the procedure and the steps that you follow are the same every single time. And if you follow those steps in the correct order, it's very, very difficult to make a silly mistake and not get the answer that is required from you. All right. So always, please, two things that I want to remind you about here is that the answer for vertical and the answer for horizontal must be in the same unit of measurement. All right. Once you have them in the same units of measurement, you can drop that unit and write it as a ratio of vertical to horizontal. And then, please, it has to remain in a ratio. In the next lesson, we're going to look at vertical exaggeration, and I don't want you to get confused between the answers in vertical exaggeration versus the answers in gradient. All right. I hope today's lesson has helped you and that you've enjoyed yourself. I've certainly had a good time. I hope that you've recorded this so you can refer back to it in your preparation for your final exam. Study hard, and best of luck to all of you guys out there. Take care.